Hello and welcome to my channel Stat Academy. The statement of today's problem is, in a frequency table, the upper boundary of each class interval has a constant ratio to the lower boundary. Show that the geometric mean capital G may be expressed as log G is equals to capital A plus k divided by n summation I ranging from 1 to r fi into I minus 1, where small n is equals to summation of fi, capital A is the logarithm of class mark of the first interval and small k is the logarithm of the ratio between the upper and lower class boundary. So we will start this problem with the frequency table, where the first column is class interval, the second column is class mark, and the third column is frequency, where class intervals are A1 to A2, A2 to A3, AI to AI plus 1, and the last row is AR minus 1 to AR, and the corresponding class marks are the middle point of the class interval. So class marks are x1, x2, xi, xr, and the corresponding frequencies are f1, f2, fi, and the last frequency is fr, and we have given that the summation of this frequency is small n is equals to summation of fi, where summation is over I from 1 to r. Now we have said that the upper boundary of each class interval has a constant ratio to that of lower boundary. So we have take this as I plus AI plus 1 divided by AI is equals to a constant term, that is C, say. So we can write A2 divided by A1 is equals to A3 divided by A2 is equals to A4 divided by A3, and so on, and the last term is AR divided by AR minus 1 is equals to the constant C. Now we take A3 divided by A2 is equals to A2 divided by A1. Again, if we add 1 in both sides, then we have A3 divided by A2 plus 1 is equals to A2 divided by A1 plus 1. So we have A3 plus A2 divided by A2 is equals to A2 plus A1 divided by A1. Now if we change the side of this, then we have A3 plus A2 divided by A2 plus A1 is equals to A2 divided by A1. So we just cross multiply the terms, or if we divide this with 2, then we have A3 plus A2 divided by 2 divided by A2 plus A1 divided by 2 is equals to A2 divided by A1, or we know that A3 plus A2 divided by 2 is the class mark of the third row. So we can write this as class mark of the second row. So we can write this as x2 divided by a2 plus a1 divided by 2, that is the class mark of the first interval, that is x1, is equals to a2 divided by a1. So x2 divided by x1, we have got this as a2 divided by a1. Again we can write this as x2 divided by x1 is equals to x3 divided by x2 is equals to x4 divided by x3 equals to equals to xr divided by xr minus 1 is equals to the constant c. So from this we can write xi is equals to xi minus 1 into the constant term c. Again we can write xi minus 1 as xi minus 2 into the constant term c. So if we replace this xi minus 1 with this, then we have xi minus 2 into c squared. In the similar way we have xi minus 3 into c to the power 3 or c cube, and the last term should be x1 into c to the power I minus 1. So we can write xi is equals to x1 into c to the power I minus 1. Now we know that the formula of geometric mean capital G is equals to pi I from 1 to r xi to the power fi whole to the power 1 by n. Now if we take, this is the formula of geometric mean. If we take logarithm in both sides of the problem, then we have log g is equals to 1 by n summation I ranging from 1 to r fi log xi. Again, if we replace this xi with x1 into c to the power I minus 1, then we have 1 by n summation I from 1 to r fi log of x1 into c to the power I minus 1, or we have 1 by n summation 1 to r fi log of x1 plus I minus 1 log of c. So if we break this sum in two parts, then we have 1 by n summation I from 1 to r fi log of xi, sorry, this is log of x1 plus 1 by n summation fi into I minus 1 into log c. We have log of x1 divided by n into summation I from 1 to r fi plus log c divided by n into summation I from 1 to r fi into I minus 1. Now we know that summation of fi is equals to small n. So small n log x1 divided by n plus log c divided by n summation fi into I minus 1. Or we have, if we cancel this n with n, we have log x1 plus this. Now we have told in our problem that the logarithm of first class mark is capital A plus logarithm of the constant ratio is small k divided by n summation I ranging from 1 to r fi into I minus 1. So we can write log g is equals to capital A plus k divided by n summation I from 1 to r fi into I minus 1. So this is our proof. So we have to prove this, and we already proved this. So that's all for today's video. Thanks for watching.